Hello, my name's Jeff Messier. I'm a professor in electrical and computer engineering in the Schulich School of Engineering at the University of Calgary. And this is my tutorial video where I explain how to set up the GNS3 simulator for ENEL 573. And this simulator is what we're going to be using to do most of our projects in this class. And I'm really excited about this simulator, and I've been using it for many years now. When I first was given the assignment to teach a course on computer networks, I imagined that, the best possible experience for my students would be, somehow getting a room filled with routers and Linux computers and having people connect wires together and hook up the computers and build networks. And while I guess that has some tactile value, the GNS3 simulator actually gives us essentially exactly the same experience, and in many ways it's better. So as you're going to see, the simulator, when we start it up, looks very much like most network simulators. There's a graphical user interface where we can drag and drop little computer icons and little Ethernet switch icons and connect them using little lines. But the real magic starts when you hit play on the simulator. So the way GNS3 works is it actually starts a separate virtual machine for each of the simulated network devices within sort of your graphical user interface. And so in our case, when we hit play on the simulator, a little Linux virtual machine will start up for every single one of the computers in our simulation. And we'll actually have a separate terminal for each of the simulated computers running a live Linux distribution. And we'll be able to log into those terminals and configure those little virtual machines in exactly the same way that we would configure real computers. And the second super cool thing about GNS3 is that when we start to send packets back and forth between our computers, we can actually launch the Wireshark packet sniffing program to do packet traces and examine the packet flows between the simulated computers. Wireshark would be exactly the same tool that we would be using to monitor traffic in a live network, and the packets that we capture within Wireshark, within GNS3, have exactly the same format as real network packets because they're being generated by fully compliant Linux operating systems running on the virtual machines on the simulated computers. And so we're using real operating systems. We're using the full version of the packet sniffing program, and we're seeing fully formed TCP/IP packets being generated by actual sort of real-time operating systems. So in this tutorial video, what I'm going to do is walk you through the steps of installing the GNS3 simulator, configuring it, and building your very first little test network where we drop some computers down, boot them up, and configure them so that they can send packets back and forth. So GNS3 is a free simulator that can be downloaded from GNS3.com, and the way you do that, you just go to GNS3.com. It's pretty self-explanatory. You can just click on the free download button. The version of GNS3 at the time of recording for this video is 2.2.12, and you will have to create an account on the website before you can download it, but it's just an email style account, and once you do that, you can download. I'm going to be showing you the how to install and run the simulator on Windows 10. This is going to be sort of our quote-unquote officially supported operating system for ENEL 573, just because I think that that's probably what most of you are running at home. However, there are versions of GNS3 that will run on Mac OS and on Linux. The installation should be broadly the same, but I won't I won't step through it for all of the operating systems. And if you want to try running this on Linux or Mac, you kind of are on your own, in a sense. You should be able to get it to work. Feel free to post questions, but we're not going to be able to put a lot of time into sorting out operating system specific problems. If you only have a Mac computer and you need to get the simulator running and you can't get it to work on a Mac, what I would recommend is you just create a Windows virtual machine on your computer and run it within that Windows virtual machine. That's actually what I'm doing right now. This is a virtual machine. I don't actually use Windows very much. So you can go through the download process. I won't do that. I've already downloaded the installation file, so I'm going to double click on it now. Next, agree, next. Now, in this little installation box, you do have to expand the tools section because there are some things that we're going to enable and disable. So we want basically all of the first few programs, WinPCAP, NPCAP, Wireshark definitely we want, Dynamips we definitely need, QEMU is definitely what we need because that is the virtual machine program that we're going to be using. CPU limit we don't need, VPCS we do not need, tight VNC viewer we do need, so leave that enabled, and solar putty we don't. So basically the first 1, 2, 3, 4, 5 optional programs plus tight VNC viewer. Something I should also mention at this point, you'll see right under QEMU there's an option to install Intel hardware acceleration, and I don't bother doing that because that doesn't work on my Windows installation because I'm running it inside a virtual machine. But if you're running Windows natively on your computer, then hardware acceleration might work for you. So you can try enabling that during your installation. It'll take you through a series of install windows. Those install windows failed on my machine because I'm using a virtual machine, but they might work on yours. So if you want, you can give it a try. The GNS3 is pretty slow, especially when we run multiple computers. Like at some point we're going to be running 5 or 6 different simulated computers all at once. So you might want to give that a try and see if it works. And if it does work for you, please post on the discussion board and just give some indication to the other students that that it worked out for you. Just click on next. And then at this point, we can largely go with the default for most of these installation options. WinPCAP install window will pop up separately. I flicked through that a little bit quickly, but by default, WinPCAP is started at boot time. Please leave that enabled because you need that for GNS3 to work. We now proceed to the Wireshark part of the installation. And then we hit next after it says completed. You can say no for your free license of SolarWinds, whatever that is. And click Finish and start GNS3. It opens a web page thank you by default, which we don't have to look at. Now you'll see connecting to server on local port 3080 or something like that. You might find that you have to disable your firewall in order to get this to work. So basically, how GNS3 works under the hood is it starts a little bit of a server that the simulated entities connect to, and it uses the localhost loopback address on your computer. If that's blocked somehow with your firewall, you may have to adjust or disable your firewall. I've got my firewall disabled because this is just a virtual machine that runs on top of my Mac, so I don't really need a lot of security on it. However, if you do need to disable your firewall to get this to work, of course, make sure you're not on a live network while you do that. Disable your Wi-Fi, unplug your computer from your wired networks, do the project, and then enable your firewall after you're finished working. So right away you'll get this setup wizard, and you can just click on don't show this again and go cancel. We're not actually going to use the setup wizard. And so this is what the simulator looks like, and now we're ready to configure our virtual machine. Okay, so now we're ready to go in and configure our Linux virtual machines that we're going to be running within the simulator. So we go to Edit, Preferences, go to QEMU. The hardware acceleration is enabled by default. Since I didn't install the hardware acceleration programs, I disable this in my installation. If you were able to install these, if you're running Windows natively and you were able to install them, leave that enabled, and it should hopefully improve your experience using the simulator. We then click on QEMU virtual machines, or VMs. We go to New. The recommended way to run QEMU on Windows or whatever is to use something. Just click on OK. We ignore that. And I'm going to call my computer 573 node. This is not a legacy ASA virtual machine, so do not check that. Go to Next. The 256 meg of RAM default is fine. The QEMU binary default is fine. For terminal, go to VNC. So this is going to start that tight VNC viewer. That's basically going to give us the terminal interface to our simulated machine. Click Next. Hard drive image. So this hard drive image is what I'm going to make available on the D2L Project 1. The Project 1 section of the D2L page, there's going to be a QEMU disk image. It's going to be quite a large image. It's going to be probably about half a gig. So download that and just copy it to your desktop. I've done that already. So desktop, 573 node image, open that. Would you like to copy this to the default images directory? You can say yes. I'm going to say no here just because I've been installing and uninstalling this a lot. I install and uninstall GNS3 a lot because I make these tutorial videos all the time. So I just click no, but you can hit yes if you want. Go finish. And then we do have to hit edit. There is one thing I would like to configure. So you can hit edit and you get a bunch more options on your hard drive, how you want the CD to be modeled, the network drive. Later on in some of our labs, we will be using more computers with more than one network adapter. So for example, router computers have to have one network adapter for every Ethernet subnetwork they're connected to. So sometimes we will increase this number of adapters to maybe 3 or 4. But for the purposes of this lab, we can leave this to 1. But just remember that this is where you increase the number of adapters when because you're gonna need to do that for project 2. We can add some, kernel command line parameters and stuff. We don't have to change any of that. The only thing we really want to change at this point is to go down to console type. This should be VNC, and we click on Auto Start Console. So that means as soon as we start the simulation, a console will be brought up for all of the simulated computers within our simulation, which is nice because we want to interact with all of them typically. Click on OK, apply, OK, and now we're ready to create our first network. Okay, so we go into File, New Blank Project. I'm going to call this project Project 1. Click OK. And then we get this blank sort of white screen that we can use to create our simulated environment. If we click on this icon, we get a list of all of the things that we can drag and drop into our simulated network. The two things that we're gonna be working with are 573 node and Ethernet switch. So 573 node is the virtual machine that we just created. And so I'm going to drag 2 of these into the simulated environment. And by default, it's 573 node-1 and 573 node-2. And I'm also going to drag and drop an Ethernet switch into the environment. Now, the next thing is to connect the 2 simulated computers together. As we're going to learn, well, actually, just to back up, so these 2 computers are going to communicate by default via Ethernet, a simulated Ethernet protocol. And as we're going to learn in 573, or maybe as you already know just from playing around with computers in your home, you can't hook, well, we typically don't hook 2 Ethernet computers directly together. You can do that with a crossover cable, but usually what we do is we connect the 2 computers through an Ethernet switch. And so to connect them, we click on this little wire icon. Then when you click on the first computer, it asks you which network interface you want to use. We only have one network interface in each of our computers, so we choose that one by default. However, if this were a routing lab or a routing project where you configured your virtual machines to have multiple Ethernet interfaces, you would see, let's say you configured the machine to have 3, you would see all 3 of those interfaces here. So we choose one. Now we've got a little line. We then highlight the switch. The switch has by default 8 Ethernet ports. We'll just hook up to the first one, and you can see we're connected now. We then click on the switch. The first Ethernet port is occupied, so we then take the second Ethernet port. Then we get another little line. Then we go to our second computer, we hook it up, and we're configured now, and we're ready to start our simulation. Okay, so you start the simulation by hitting the green play triangle, and once you do that, this is kind of where, I mean, for me, the magic happens. I still think that this is cool. So as soon as you start the simulator, we have 2 terminals that pop up, and each of these terminals, you can see the first one corresponds to 573 node-1. The second one corresponds to 573 node-2. And these are the terminals that allow us to interact with the Linux operating systems that are being booted for each of these 2 machines. Now, the simulator, I mean, one drawback of GNS3 is that the simulator is a little bit on the slow side. So it can take a little while for this to boot. It gets even slower once we simulate 5 machines. Hopefully this is a little faster if you can get hardware acceleration working, but it's not too bad. And again, the super cool part about this is basically equivalent to hooking up 2 real Linux computers in the lab. This is a full version of the Linux operating system. Now, one thing I'll also say while we're waiting for these 2 machines to boot up is, you'll notice that the interface that we get to these 2 simulated machines is just a raw text terminal interface. And some of you may have used Linux in the past and will have likely used the Linux Windows system, which kind of looks like most, it looks like Windows 10 or Mac OS. You can start a web browser and you can run, different kinds of programs. And this sort of text-based terminal interface is pretty raw. And not all of you may have had experience interacting with Linux computers on this level. But I really want to give you this experience because if you end up working with configuring network devices, whether they're Cisco routers or whatever network device, typically it is through kind of a very sort of basic text-based terminal sort of interface. And so I think it's important to have some experience and a certain level of comfort working with operating systems on this level. So in order to navigate this environment properly, you will have to be familiar with some of the basic Linux commands, like how to change directories, how to list files in a certain directory, how to copy files, how to move files. And if you don't have that experience, there are a huge number of tutorials online. So, take 45 minutes or an hour, go through those tutorials and get that, get that background. So now you can see both of these computers have finished booting, and we have a login prompt here. We're going to log in as root, and the password, I've configured the password on these virtual machines for there to be no password. So just hit enter and you log in. At this point, I would like to give a big warning. Never ever use a blank password for any computer that you're administering, particularly the root password. So the root user on a Linux operating system is kind of like the super user administrator account, and you can do anything. You can delete the whole operating system by accident. You can look at users' files. You can do almost anything. And to have the root account have no password is ridiculously insecure. For us, it's fine because we're just working with these machines within a simulated environment, but never ever, if you're a network administrator, do something like this. So, as I said, we need to be able to navigate the Linux operating system. And the very first thing that we're going to do is we're going to configure the IP address of these 2 machines. Now, at this point in the class, we most likely haven't covered IP addresses yet. So this is something that we're going to talk about later in the course. But just for the purposes of getting the simulator up and running, I'll show you how to do it, and just understand that we're going to learn a lot more about IP addresses as the class progresses. So we need to go into the directory etc network. If we list the files here, there's a file called interfaces. And interfaces is where we configure the IP address of our Ethernet card interface. So I'm going to edit the interfaces file. I'm using a text editor called VI. If you haven't used VI before, it's a very basic command line text editor, and it's a little bit strange. You navigate by hitting different letters, and when you want to type, you have to press I for insert, and then you type in things. So if you haven't used VI before, again, check out a tutorial. You'll learn how to use it fairly quickly. It is very primitive, but the nice thing about VI is that you always have VI. It doesn't matter how basic your operating system, Linux operating system is, it will typically have VI available for you. Whereas like the other editors, Pico, Emacs, stuff like that, aren't necessarily always involved or installed. So if we look at the interfaces file, I have commented out the ETH0 lines. We're going to uncomment auto ETH0. So that means that when the Linux machine is booted, it will automatically bring up our first Ethernet card interface. These next two lines configure the Ethernet card for the DHCP dynamic IP addressing protocol. We're not using that. Instead, we're going to give this interface a static IP address. So we go down to the end and we replace DHCP with the word static. We delete this hostname line and then tab, type the word address, and then we're going to give this first computer the address 192.168.0.1. And then on the next line, hit tab again, type net mask 255.255.255.0. Again, we're going to be learning all about IP addresses and net masks, network IDs, all that kind of stuff later on in the course. For now, just type this and know that, as the course progresses, you'll understand what all of these things mean in due time. That's the modification that we need to make, so that we then write and exit. And now we use the command if up to bring up the Ethernet interface. So we go we type in if up, which stands for bring up interface, ETH0, enter. There is also an if down command to bring down a particular network interface if you're sort of changing its configuration. So to check that we have properly configured our Ethernet interface, we then type the command ifconfig, which will give us the configuration for each of our network interfaces. Hit enter, and then you should be able to see up here ETH0, and it gives you a whole bunch of information, but on the second line, INET address 192.168.0.1 and mask 255.255.255.0. Those are the two entries that you need to check. Those correspond to the information. Those two entries correspond to the information we put in our interfaces file. That checks out, so we've configured things properly. Now we're going to go down to the second computer and give it the IP address 192.168.0.2. And I'm just going to do that, following exactly the same steps. Oops. So same steps, obviously just the address is different. Exactly the same net mask, and you'll see why that is when we talk about net masks later on in the course. IF up, Ethernet 0, IF config, and when we check it, it checks out 192.168.0.2, and the net mask is the same. So we've configured our computers to have valid IP addresses, and now we're ready to send packets between the two machines. So before we start to run some network programs that send packets back and forth, I want to start our packet trace so we can actually observe the packets that are being sent. And so in our simulation window, put the cursor over top of the network connection between node 1 and the Ethernet switch. You'll notice that it glows red. Then right-click, hit Start Capture. This default stuff is fine. and make sure that start the capture visualization program is checked, and that is going to automatically start Wireshark. A little magnifying glass appears to just indicate that we're tracing packets along that link in the network. And the Wireshark packet trace program will pop up in a moment. It just takes a little bit of time. So the Wireshark program that says finding local interfaces, you can actually use Wireshark to look at the network traffic that is passing back and forth on real networks. So you can like connect it to your Wi-Fi interface or your Ethernet interface on your actual computer. Of course, we're not doing that here. We're connecting it only to the simulated interface within our machines. Already, if you look in Wireshark, we can see that we've had 2 packets sent. When you highlight a packet, you get sort of a hex readout of the actual binary content, but then you get a more human readable breakdown of the different protocol or the information stored in the header of the packet for the different protocols that the packets correspond to. So this particular packet uses the Internet Control Message Protocol. This is just some overhead messaging that's sent back and forth between the machines. We're not going to look at it too closely, but you can see there's Ethernet information in the packet as well. So the first thing that we're going to do to cause a little bit of packet traffic is we're going to use the ping command. Now the ping command is a very useful command for troubleshooting network connectivity. So you've connected some computers, you've configured their addresses, maybe they go through a switch or a router, and you just want to know if one computer can reach the other one. And so in our second computer, I want to know if we're connected to the first. And so the first computer has IP address 192.168.0.1. And so I'm going to type in ping 192.168.0.1. And this is going to send some just sort of test packets to simulated computer number 1. And then the simulated computer number 1 is going to reply back. So if I hit enter, you can let this go for 3 or 4 packets, then stop by hitting Control C. And you can see that we've sent packets to 192.168.0.1. It tells how long it took to get a reply back, 421 milliseconds. Then we do it again and again and again. So there's 4 exchanges. And if we look in the Wireshark window now, we've got a bunch more packets to look at. So we can see we've got a ping request, a ping reply, request reply, request reply, and request reply, request reply. So we have 5 exchanges. Only 4 were displayed because I hit Control C before the 5th one was able to be displayed. And we can click on each of these packets and look at the information contained in each of the packets. Don't worry about all of the details here. We're going to, as the course progresses, talk about what a lot of these fields mean. What you're checking for right now is to just make sure that you can see the traffic showing up in Wireshark and that you can click on a particular packet, an ARP packet, and understand what and just see that it's been recorded. So another way of generating packets between 2 machines is to use a client-server application that I actually wrote custom for ENEL 573. And we're going to designate node number 1 as the server, node number 2 as the client. And so on node number 1, you type in the command server, hit enter. It asks for the IP address of this computer. So that's 192.168.0.1. Then you have to add up the digits in the student numbers of your group members. And so I give a little example here. So if you've got 2 people in your group and your student numbers are 3, 0, 0, 0, 0, 1, 2, 3, and 9, 0, 0, 0, 5, 4, 3, 2, you would add 3 plus 1 plus 2 plus 3, and then plus 9 plus 5 plus 4 plus 3 plus 2, and you get the number 32, and that's the number that you would enter. The reason why I do this is because it generates a custom traffic profile for every group, and that prevents just one group from just taking and using the traffic file of somebody else. So the only way to generate the traffic file specific to your group is to actually implement the computer network and generate the traffic yourself. And it kind of verifies that the group has been able to get the simulator up and running. And so in this case, it's 30. For the example, the number is 32, but it's going to be different for your group. So let's say the number for my group happens to be 74. So I hit enter. And now the server is configured and is waiting for a connection. So I go down to computer number 2 and I type in the command client. So it asks for the server computer IP address, which is 192.168.0.1. Hit enter. Again, you have to enter the sum of the digits in your student number. I used, for my hypothetical example, I used the number 74, so I have to type 74 down here as well. And you'll see that some messages are then printed to the screen. Down in the client window, sending message to a server, receiving client messages, packets 14 out of 14. Up here, packets 14 out of 14. For your particular project, you might not get 14 packets. This number is going to be different depending on what number you put in for the sum of your student numbers. And when you go over to the Wireshark window, all of a sudden now you're going to see a bunch of UDP packets. And so if you click on a UDP packet, you'll see the protocol information buried in the binary contents of the packet. You'll see a message, hello. Then the next one will say again, hello again, hello again, and so on. So these packets are traveling from, you can see from the source is the client IP address, the destination is the server IP address. A little bit later on, you'll see the server replying back to the client. And you'll also see some ARP commands as well. If we rank this according to time in the Wireshark window, that gives us a little bit, a little bit better idea of how these packets were exchanged chronologically. So that's basically it. So this is the conclusion of the first part of Project 1. So if you reach this point, you will have been able to set up the GNS3 simulator, configure a little test network, start the simulation, boot your computers, configure the IP addresses, generate some traffic between the two computers, both using ping and my client server command, and be able to capture everything in the Wireshark window. The last thing we have to do now is to stop the Wireshark capture and save these packets to something called a pcap file. So if we go save, there's the option to do pcap-ng. We actually don't want to do that. Select instead the pcap file. So that's the second choice. And then give it a name. I'm going to call it project 1, hit save. And this project 1 PCAP file, this packet trace, is something that you're actually going to be working on later on the project when you write your Python traffic analysis script. But for the first part, you're all done, and this concludes the tutorial video.